We will discuss the continuity of a function. The continuity of a function can be basically divided into two parts. One is continuity of a function at a point, that is continuity of a real function f of x at a point C which is in its domain. So this is continuity of a function at a point. Now let C be a point in the domain of f of x, then f of x is continuous if limit as x tends to C f of x is equal to f of c. Now we have to be elaborating this. Now it necessarily means that the value of the function at the point C, that is f of c, should be equal to the left hand derivative, which is limit as x tends to c minus, which is a point very slightly less than c of f of x is equal to limit as x tends to c plus f of x. So for a function to be continuous at a point C, it is necessary that the value of the function at that point coincides with the left hand limit, that is limit as x tends to c minus f of x should be equal to the value which is the right hand limit, that is limit x tends to c plus f of x. Now this is the continuity of f of x at a point. Now what about the continuity of a function itself, that is in whole of its domain you want to find the continuity of the function. So this one is if a function f of x, now whenever we say a function, it's all real functions, real function is continuous in its domain if it is continuous at all points in its domain. So now this requires that take any point in its domain and at each point in the domain of the function, if the function is found to be continuous, then the function is said to be continuous. So this is called as continuity of a function itself. Now in continuity of a function, we have to discuss about its algebra. That is algebra of continuity of functions. Now if f of x and g of x are real functions, then if f of x and g of x are also continuous, then f of x plus g of x is also continuous, that is the sum of two continuous functions is again a continuous functions. Similarly we have f of x minus g of x also to be a continuous function, that is the difference of two continuous functions is again a continuous function. Now we have f of x into g of x also to be continuous, which means that the product of two continuous functions is again a continuous function. Now if f of x and g of x are continuous, then f of x divided by g of x, that is the quotient f of x by g of x is also continuous, but here we have a condition that g of x is not equal to 0. Now consider cases 3 and 4. Now this enables something like this. Now if f of x is a constant function, say f of x is equal to k, where k is a real number, then we have f of x into g of x is equal to k into g of x, which means that a constant time g of x is again a continuous function. Now suppose if k is equal to minus 1, we get f of x is equal to minus g of x, which means that the negative of f of x is also a continuous function. F of x is a constant, say lambda, then lambda by g of x is also a continuous function. Specifically, if lambda is equal to 1, it says that f of x is equal to 1 by g of x, which is the reciprocal of the function g of x, is also continuous. Now, these properties enable us to create a lot of continuous functions, so we can have a host